Hello, my name's Paul Fieguth. I'm a longtime professor in system design engineering at the University of Waterloo, and I'm delighted to tell you a little bit about the biomedical engineering program today. I guess my little connection is that I was department chair when the program was initially conceived and begun. And so I've got a sort of a little sentimental attachment, you could say, to the program. And I've really been pleased to see how it has developed and grown and sort of over time. And so I'd love to sort of share with you a little bit about the program and hopefully get you excited about it too. So biomedical engineering is a relatively new program, but it's an exciting one, and it's one that has really a lot of opportunity, a lot of sort of new directions for sort of students to develop careers and sort of take sort of co-op and all these things as sort of a unique way. So what is biomedical engineering? Well, at a high level, it's an interdisciplinary program with an emphasis on biomedical systems. Well, what does that mean? Well, it means that it is an engineering program, first of all. It's definitely not sort of bioscience or pre-med. It's an engineering program, but it has a particular emphasis on the sort of the biomedical aspects, whether that means sort of human or sort of health more broadly, and we'll get back to that. It's a unique program, and it sort of inherits certain, let's say, systems engineering like traits because its parent department, so to speak, is system design engineering. So I'd like to think that it sort of benefited from some of the unique and sort of strengths of system design, and particularly a systems approach and a design emphasis, and combine that with a really heavy sort of dose of biomedical sort of content to create a unique program that has a lot to offer. So the program is technically housed or hosted by the Department of System Design Engineering, but we bring in professors from 4 other departments, and so it really is interdisciplinary that way. The students will get exposed to a variety of sort of professors with different backgrounds, some labs in biology, other labs in engineering, and but I think that ends up being a really good experience because it lets students, like the whole point is for students to get to be able to say both talk with doctors on the one hand or with computer scientists and engineers. And so if we don't have some of that multifaceted experience in the program, it'd be hard to say that students should be able to do that after graduation. So I think that's a pretty unique and sort of important part of what students will experience while they're here. So let's back up a step. What is engineering? So technically the degree that a student would get is a Bachelor of Applied Science, meaning you're applying science, right? So we study a fair bit of physics and biology and math, but we don't study them just to study them, although it is fun, right? Don't get me wrong. But we're studying it in order to satisfy certain objectives. That is, we want to do something. And so that's the whole point of engineering, is accomplishing some goal, but using a whole variety of tools in your toolbox. And that's what we need to develop over time. Okay, so biomedical has a strong design component. Then what's design? Well, design is essentially a systematic process, ideally systematic, to generate, specify, and evaluate solutions to problems. Well, what does that mean? Well, design is essentially the creative side of engineering. So in engineering, we have to study a lot of math and physics and biology. And so that's essentially tools, facts. But that on its own doesn't yet make you an engineer. So now we have to sort of go to the other half of our brain. That's why I'm sort of holding my head here. We have to go to the other half of our brain and sort of switch on the creativity and say, how do I sort of put these tools together? Or how is it that I can pick that problem apart and look at it in a creative way? That's design. So it makes design hard to teach. On the other hand, it also makes it a lot of fun to do because it's not just a matter of, fill in the blanks or sort of turn the crank and get the solution. In fact, design doesn't work that way at all. It takes a fair bit of brainstorming, false starts, some prototyping, but ultimately, that's what makes you a good engineer. So what we're trying to do is combining sort of systems thinking and biomedical. And so here's one quote for you to look at. So over 50 years ago, really it was electrical and mechanical where that sort of dominated engineering. And there's quite a lot of people who think that there's a significant transition now to sort of more interdisciplinary, or let's say systems-like thinking, that will be making a big difference. And in particular, this quote was referring to healthcare. And so quite relevant to BME. So biomedical systems then is essentially interconnected elements, that's the system part, but where these interconnected elements have some kind of biomedical function or purpose, all right? And so we're interested in innovative approaches to real-world actual biomedical problems. So the BME curriculum is fairly unique, and it's important to emphasize a few things. One is we have actual biomedical content in about 80% of our core courses. Now, that may not strike you as particularly unusual, but I guess I want to emphasize there are a lot of biomedical programs out there meaning in Canada, which are essentially a bunch of biology courses and then a bunch of either chemical engineering or electrical engineering courses. Now, I don't want to sort of speak badly. There are lots of universities that have great programs, but I'm not convinced that just taking a bunch of biology courses and a bunch of engineering courses makes you a better biomedical engineer, because we're leaving the integrative process, the process of actually trying to build the connections, we're leaving that 100% to the student. Okay? Instead, what we're doing is all our core courses have biomed content. So for example, if we're teaching first year programming, we told the person who's teaching the programming course, you know what, you're teaching biomedical engineers, you want to kind of use some sort of case studies or motivations or contexts that are sort of biomedical-like, or say digital circuits or statics or dynamics. All of those courses, because Waterloo Engineering cohort-based, meaning all the students in the classroom are from one program, that way we can actually focus or dedicate what might be generic material like, say, first year physics or programming, and we could actually make it relevant to that particular discipline. So how we teach programming to mechanical engineers would be very different from how we teach programming to biomedical engineers. And so that's one big, unique piece of the BME curriculum here at Waterloo. And then other things like we have a design course every term that's inherited sort of from the systems design sort of emphasis, and a fair bunch of labs and lots of flexibility. We'll get back to that in a moment. So here's the curriculum. Admittedly, a little bit over busy and overcomplicated. Let's not worry about the details. In fact, a lot of those course titles won't really make much sense to you, and that's okay. What we want to emphasize is really the interdisciplinary nature of the curriculum that we're looking at here. So what are all these blobs? So we have a bunch of dark purple blobs. That's design. So you can see there's a fair bit of it. We have some every single term. That's great, because honestly, when you're an engineer, you get a lot of technical courses. And at some point, your brain's like, I can't absorb much more. And the design courses are your chance to sort of let the other half of your brain do something a little bit more creative, a little bit more different. In my opinion, it's a sort of really welcome, let's not say relief, it's kind of a welcome alternative or welcome change from sort of the other more heavy technical material. And since design courses are actually meant, like it's a place where you're starting to apply the tools in your toolbox. Well, those tools are what you learn in your other courses. So a design course is really quite motivating because it finally lets you actually try to use these other ideas that you're learning in other courses. And so there we go. So that's dark purple. Then a light purple is sort of math. So there's a fair bit of that because we need to sort of model and represent, simulate things. Then the green is engineering science. And so that will include a sort of fair bit of sort of biomedical, sort of biology-like courses. And then we have a smattering of other ones, particular digital and physical systems, and then the white ones are all your electives. And you'll notice the electives are mostly in the last year. So on the one hand, yes, it's a while to wait. On the other hand, we kind of need to build up the whole background so you got all the fundamentals in place before we start giving you more open-ended kinds of courses. So it works out. All right, so the biomedical engineering program is largely divided, at least conceptually, into 3 theme areas, which I'm quite excited about, and which are largely inherited from the existing strengths in system design. So that actually makes lots of sense, because if we have a bunch of professors in system design engineering teaching biomedical, obviously we want to build on what they're really good at, what they're passionate about, and what they can uniquely bring to the program. And so indeed, that's what we have here. So, and furthermore, biomedical can mean lots of things to lots of people. So let's just clarify a little bit here what it means to us. So we would like students and broadly our program to be really good at biomedical signals, biomechanics, and biomedical devices, which basically means things I can measure about the body, that's biomedical signals, things about the body moving, that's biomechanics, and things that I can do to the body, that's devices. And so we need to think about these in fairly broad terms. So signals could include an MRI, that would be an obvious example, but it could also be, say, measuring just body temperature or conductivity of my skin. Biomechanics can involve, like how joints move and things like that. But it also includes something fairly fun like sports. And so, in fact, sports engineering is one of the pieces that we have in our program. Biomedical devices includes very cool things like, I don't know, some weird implant in the brain or, sort of inner ear, but it also includes much more everyday things like, say, a crutch or a wheelchair. Ultimately, you may say, well, crutch, yeah, we've had those for 100 years. Sure, but if the crutch is made out of poor material that chafes and ends up giving you a sore, then that's not very pleasant. And the engineer who can build a better crutch is well on their way to having a huge impact in terms of human sort of health and satisfaction. So don't be too quick to sort of dismiss things that seem like they're everyday. So there's a lot of room for all three of these areas to do sort of interesting creative things. So one of the things that I find hard to understand is that most engineering programs in Canada have a pretty narrow view on electives. Now that has to do with how the accreditation program runs, and that's a detail that you don't want to have to know about. Because what you want to know about is what can I learn, what kind of courses can I take? And I agree, that's what you should care about. And so biomedical and systems design essentially accredit every student individually instead of the program as a whole, and that allows us to give you a lot more flexibility. It's not that difficult, it's basically a spreadsheet, but that opens up from a few technical electives to choosing, well, there's 60 biomed ones, and of course, even as a biomedical engineering student, there's no rule that says you can only take biomed electives. Indeed, you can take all kinds of electives from science or the rest of engineering. There are also what are referred to as CSEs, complementary studies electives. So those are non-technical courses, and there are literally hundreds of those to choose from all over sort of different programs in arts and applied health sciences and others. Of course, there are lots of opportunities. You can go on exchange, you could specialize or perhaps not. You could work and do an undergrad term in a research lab. Really, the opportunities are all there. It's a question of what would you like to do. So it is true that Waterloo has a lot of entrepreneurial activities going on. And so on the one hand, that's great. And so for those of you who are interested, that's wonderful. On the other hand, I also want to, I guess, reassure you, if you're the kind of student who thinks, well, I'm not sure I'm so entrepreneurial, is Waterloo engineering still going to be okay for me? Yes, it is. Okay. A certain very visible fraction of our students end up doing entrepreneurial things, but most do not. And so you will completely feel at home and fit right in, even if you're not the entrepreneurial type. You can go to some of the pitch events and you can support friends who are doing this kind of thing. But I really want to make sure that you're not feeling intimidated. It is completely okay. I myself, I did my undergrad at Waterloo. I'm not really such an entrepreneurial person, but I admire the people who are, and I love going to the events and supporting the kinds of initiatives that they're taking. There are indeed a variety of research opportunities. This is pretty important because, well, certain engineering fields lean more heavily on sort of student ability to do research, or at least creating opportunities for that sort of after the undergraduate degree, and biomed is one of them. So again, does it mean you need to do research? No. Does it mean you have to come in from high school having had research experience? No. But if you're keen to try it, or you're interested, or you might like to consider it, we have opportunities. And so there's what's known as a URA, that's an undergraduate research assistantship. That's fairly non-intimidating, fairly part-time kind of opportunity to get connected with a professor in a lab. You can volunteer in research labs, you can volunteer with student teams, and there's lots of co-op opportunities in both Waterloo research labs and research labs elsewhere. So indeed, the biomedical engineering program is co-op. 100% of engineering at Waterloo is co-op, so you can't do engineering without co-op. So where do BME students end up going on their co-op terms? Well, the answer is to some extent all over. But we're super happy to see the fraction of jobs that are sort of biomedical related, going from around 2/3 in first year up to sort of 80% in second year and onward. And so honestly, it's not that some students couldn't find biomed jobs. It's that, frankly, a lot of biomed engineering students have a variety of interests, and they don't necessarily just want to do biomed co-op jobs. So the biomed related jobs are there, but obviously as a biomedical engineer, you're also allowed to apply to other kinds of jobs. It's based on what your interests are. All right, and so you see a few companies here. There's a variety of Canadian ones, also a variety of international ones. The point is there are lots of opportunities. So I want to just really briefly recap key features. What is it about biomedical engineering that should make you want to come? The curriculum is unique. It's not just a bunch of courses from that department and that department stuck together and then you figure it out. That's not at all what it is. It's cohort-based. The entire program is like all the students in the class are all biomedical engineers. They're doing it together, and the professors come to you and are teaching you whatever it is, physics, programming, circuits, in the context of your program. And so circuits will be taught in terms of, how it relates to the body and resistivity of skin and things like that. And, programming would relate to, say, programming a microcontroller for a pacemaker or something like that, right? That's how you make it relevant. So we got biomedical systems that is trying to look at questions of biomedical in a slightly more abstracted, generalized way, such that we understand sort of systems properties, systems principles. We have a lot of design, which I think is terribly important, because if you can't design something, you don't actually really understand it. And we try to emphasize experiential learning, largely through co-op, but also in other kinds of ways. And there's lots of collaborations, both within engineering and outside of engineering. So our vision of biomedical engineering is essentially training new generation of engineers to solve real-world biomedical problems. That's what we would love you to go out and do. So welcome to our community. And it's been a great, wonderful experience. The program, although I said it's new, that doesn't mean that it's, sort of weird or sort of untried and untested. We've had several years of students already graduate from the program, have been very successful. The program has lots to offer, and we'd be delighted to see you as part of it. So unfortunately, me being online and the conversation being only one way, I can't answer your questions. So let's just take a really quick look at a few questions people might ask, like, my son or daughter has never lived away from home. What is residence like? Well, admittedly way back when, but I was a UW undergrad student. I lived in residence. I really enjoyed it. It was a great part of my experience here. Waterloo does guarantee residence to all first-year students. So once a student is here, then obviously they can kind of, students then get to know what their options are like and so forth. And in second year and onward, will make their own plans. There are many, many options. So if you just look up UW Housing, their webpage describes the various residences. There are some very large, some very small. Some have like live and learn communities, some even particular to engineering. So check out your options. Next, is my son or daughter going to make friends? Absolutely, of course. That's one of the big benefits of the cohort system. The students are not just kind of thrown into huge classrooms with 500 students and sort of mixed up at random. That simply does not happen. Class size will typically be around 80 to 100. In electives, it'll be smaller, maybe more like 40 to 60. I realize that 80 students sounds like a lot coming out of high school, but really it's not so intimidating. The rooms are not so big, and it's definitely not 500. And so because it's cohort-based, the students will have recreational kind of teams and class parties and things like that. The students connect in a way that's just simply not possible if it's not cohort-based. How much free time do students have? Well, not a lot, but largely it's because they like what they do and the program's challenging, and students want it to be challenging. We rarely have students telling us, you know what, by the way, make it easier. One of the things that makes students so successful after graduation is the fact that they learn so much and they are so capable. So we are quite conscious of trying to keep students well in terms of their mental health, but we're also quite conscious of wanting to really challenge them and ensure that by the time they graduate, they've had a fantastic preparation. What was workload like in 1A? So we are really careful. We realize that the transition from high school to 1A undergraduate is very difficult. You're changing maybe cities, you're changing context, you're living away from home. There's lots of stuff that's different. And so we, allocate extra resources, extra teaching assistants to try to ensure that students have the kind of support they need. So 1A is challenging, but I guarantee you, we don't admit anyone and then not be interested in them succeeding. That is, everyone who comes, we want them to succeed. And so we work hard to make that possible. How does co-op really work? Well, it is a little bit complicated, but we're going to help you out with that. So can my child work on improving the resume? Sure, I suppose so, but we'll have people who will work with you on sort of making your resume sort of more complete or sort of looking more attractive to an employer. So that's the kind of thing we work on in first year. So hopefully that gives you a couple of sort of ideas to get started here. If you'd like, there are lots of resources that are available online, and we have campus tours and things like that. So please do avail yourself of what the University of Waterloo Engineering has to offer. And I'd love to look forward to seeing you here at some point in the future. Thanks a lot.